Good morning, everybody. My name is Gary Langevin, and this is Brendan Murray. We are Team Bosch, and this is our capstone project for the HVAC simulation and failure data analysis. So the project motivation for us was for our team to develop a prototype that was capable of performing simulations on components inside the HVAC system. In doing that, it would also allow to acquire real-time data that could be used towards future analysis. We'd also need to use various sensor arrays to monitor the components inside that system. And our prototype would also have to be versatile enough to work on any of Bosch's HVAC products. So key accomplishments made during this project, listed from most difficult to least as far as level goes. We custom built and designed 2 printed circuit boards. PCB number 1 went into control box 1. We have PCB number 2 that was set up for the sensor arrays. We developed control box 1, which is used for emulating the controls. Programmed 2 microcontrollers that's used to control the hardware. Developed a graphical user interface, which is used for monitoring the system. And we designed various sensor arrays that go inside the IDS unit. We're proud to say that the anticipated best outcome for us was achieved. So the HVAC system overview and what we started with is the Bosch thermostat and the inverted ducted split unit. The thermostat is capable of handling 7 individual 24-volt AC signal that it sends out to the HVAC unit. With built-in relays inside that thermostat, it handles the on-off state of all the components inside the HVAC unit. The IDS unit consists of the condenser unit and the air handler unit, and uses 4 out of the 7 signals coming from the thermostat. So at the beginning, our system architecture, what we needed to do was to implement CB1 in between the thermostat and the HVAC unit that would allow for simulation and also thermostat control to still run. CB1 inside of that, you can see PCB number 1 and the microcontroller. Inside the HVAC unit, we have CB2, which is the sensor array, which consists of PCB number 2 and the microcontroller on it. So this is the prototype that we built and designed. This is a Hammond board, which is typical in a testing environment. So this is how it was put together. We have the 24-volt AC power coming from the HVAC unit. The 7 individual thermostat controls coming in from the thermostat. The 7 individual HVAC controls going out to the HVAC unit. The 7 individual single-pole double-throw switches. These switches have 3 positions, which for up is thermostat control, down being for manual on, and middle being off. We also included a manual override switch to control all of the on-off states of the signals. So for CB1, this is the internal wiring, and it shows PCB1 and the microcontroller that is stacked on top of it. And now Brendan can talk further detail about the project.
The image shown here is the final system architecture that we came up with. First, the signals from the thermostat are fed to a set of switches. As shown in the previous slide, these switches are used to manipulate the signals going into the HVAC. Next, a set of relays is used to step the voltage of these down to about 5 VDC for the microcontroller. The microcontroller is then used to output the data to the GUI that we developed via USB connection. A second set of relays is used to step the voltage back up to 24 VAC for the HVAC to handle. The first thing we did was create a custom printed circuit board to house the circuitry required for this control box. This included both sets of relays, the connection for the microcontroller to plug into, a real-time clock terminal for timestamping the data going out, as well as additional analog and digital IOs. We also created a second printed circuit board to house the circuitry required for the sensors. This included the temperature sensors, current sensors, voltage sensors, as well as a connection for the microcontroller and additional analog and digital IOs to accommodate any future sensors that you would want to put into the system. These are the final products that we came up with. Shown on the left is the PCB for the CB1 control box. Shown on the right is the PCB for the sensor array. We can proudly say both of these are functioning properly and are currently installed in the system. This short video shows a typical application of the system we created. Let's go. First, the user is setting the position of these switches to control the component. In this case, it is taking it directly from the thermostat. Next, the signal is programmed on the thermostat to control the blower fan. In this case, it is turning it on, and as you can see, it will turn on. The signals are then sent through the control box to the GUI for scanning. And finally, the signal is cutting the power to the fan, which in turn turns the fan off, as you can see. Let's go. One of the key components of this project was to be able to capture the data that we are acquiring from the system. The way we accomplish this is by simply taking the 7 signals that we are already sending to the HVAC, as well as an additional bit of data from the manual override switch. These 8 bits are compiled into a single byte of data and are updated and sent to the onboard serial port of the microcontroller once per second. A receiving computer then plots the data on a GUI, which is also used to store the data. This is one example simulation that is run on the GUI. On the top left, you see a set of switches or set of buttons that is used to control the simulation, followed by a text box that displays any errors the GUI encounters. Finally, you can see all the graphs are used to plot the key points that are currently occurring in the system. This makes debugging the system much easier. Thank you.